In this video, I'm going to look at proportion using similar triangles. The key idea here is the lengths of corresponding sides of a similar triangle. This is the key idea. They're proportional. There are essentially 6 concepts in this one little sentence, so let's take a look at these. First of all, let's look at the idea of a triangle. What is a triangle? Well, here's one, and it means tri, meaning 3 angles, right? 3 angles. So we have an angle in this location, one here, and one here. 3 angles for a triangle. And if I label these, say, A, B, and C, their degree measure, A plus B plus C, if I add all those angles together, I should get 180 degrees. That way it's a triangle, as long as all the sides are joined, right? Now, the other piece that this key idea has in here is this idea of sides. So I'm going to label these, give it another color, sides. So the sides of a triangle, let's call this small c, this side small b, and this side small a. It's often done where the angle capital A has a corresponding side, or small a that's opposite it. It just kind of locates it. So this side is a straight line. The length of the side is simply the distance, like the distance from here to here, this distance would be the distance A. So A would be some sort of measure. So A, B, and C are distances. And we talk about the length of the side. So we've looked at 3 ideas. We looked at triangles. What are they? The idea of they have sides and that each side has a length. In this picture, I'm looking at the idea of what we call similar triangles. I have 3 triangles shown here. Now, I've done my best to make them similar, so we're going to assume they are, and I'm going to define what that means. If I look at the angle here that I called A, that angle is the same angle as this, and is the same angle as this triangle. So all of these triangles have the same angle measure for that particular angle. If I look at another, say this one, this angle has a particular measure. It would be the same as this one and would be the same as this one. If this were 90 degrees, this would also be 90 degrees, this would also be 90 degrees. So they all have the same angle measure. If the orange ones are the same as the pink ones, then clearly, because they all add up to 180, these angles have to be the same. So notice each of these triangles, all 3 of these triangles, have the same angles, internal angles, right? But their sides are different lengths. This length A is different than this length I'll call A prime, which is different than this length A, call it double prime. Alright, so each one of these are different, but their triangles are similar. They're just either kind of zoomed in or zoomed out. And we call these similar triangles. They have the same angle measure. So the key idea says if I have a triangle and they're similar, their corresponding sides are proportional. So what's a corresponding side? Well, A prime, and A double prime here are all corresponding sides. It's the same side opposite the same angle. So the orange angle in the large triangle is A double prime. The orange angle in the middle triangle is A prime. The orange angle opposite that is side A. So let's look at this idea of proportionality. So I'm looking at the similar triangles. I'm going to tell you these two are similar. In other words, just look at these top two. This orange angle is the same as this orange angle. Maybe it's 9 degrees or something like that. But they're both 9 degrees. And we'll say that this particular angle over here, the yellow one, is the same degree as that. And the pink one up here, the large obtuse angle, is the same as this one. All right, so we know these are similar triangles. Their lengths are a little different. So let's call this side C, and let's call this C. I'm going to put subscripts. I'm going to call this C sub 1 and this C sub 2 for the first triangle and the second triangle. These are corresponding sides. C1 corresponds to C2. If I pick this to be A sub 1 and this to be A sub 2, then A1 and A2 are also corresponding sides. And what they're telling me is, in this key idea, is that they're proportional. That means I can set up a ratio between these sides and set them equal. What it means is that I can take the ratio of the first side, C1, and divide that by C2. That's a ratio of these two corresponding sides, and I can say that's equal to the ratio of the other corresponding side, A1 to A2. Now notice in the numerator I have the smaller triangle, and in the denominator I have the larger triangle in both of these ratios. So this is the key idea. Now sometimes these angles don't always show up quite as clearly, like in the two triangles below. Let's take a look at these. This angle certainly looks like this one, right? And we'll make this tiny angle, this kind of pointy one, orange, and that corresponds to this one. And then I'll make a green angle this one. So this one now must be the green angle. So the angles actually orient the sides. So I'm going to give these sides different names. I'm going to call this A, B, and C. And I'm going to call this D, E, and F. So when I set up my ratios, I want to make sure that I'm got corresponding sides. I can look at and I can say B and E can be set up as a ratio. So B divided by E is one ratio, and the corresponding side, well, A goes between the yellow and orange. What goes between the yellow and orange angles on the right hand side? That's right, F, not D. D goes between the green and orange. So I could put A, which goes between the yellow and orange angle. I could put A, and its ratio, yellow-orange, is F. But there are three. So actually I could have said B over E is equal to C. C now is going between green and orange, so I come over to this triangle and I say D is between green and orange, so it's C over D. Okay, so let's try an example with some numbers. Alright, here are two triangles. I'm going to say that they're similar. I'm just going to tell you that. Alright, and because they're similar, that means their corresponding angles have to be the same. So we can look and we can say, well, there's a large angle at the top here, and there's a large angle at the bottom here. So those must be the two sort of associated angles. And a typical way, rather than using colors, is to mark it with the semicircle and then put little tick marks in that. So if I had put 3 tick marks into this semicircle, I'll put 3 into this. So that tells me these two angles are the same measure. If this is 105 degrees, this one's 105 degrees. Alright? And then I look and I say, alright, well, here's a very small angle. I'll measure it and I'll say that's just 1 tick mark, and it would correspond with this angle. So we'll say these two angles are the same degree. And really that's all I need, but I'll put in that 2 tick marks for this one. That angle would have to equal this angle. Alright, so now I know for a fact they're similar because I'm telling you they are. Never really trust a drawing because often a drawing is just a sketch. Go with what's being told to you around which angles are equal. So let's say we started here and we were also given that this length was 2 and this length is 5. So this is the beginning of the problem that's handed to us. And then we have this distance we don't know, we'd like to find it, and this distance is 10. Alright, so we want to find the length of x. That's the problem. And we've been given these two sketches, these two triangles. I know they're similar, so I know their corresponding lengths are proportional. So let's set up a proportion. 2, this distance 2, goes between an angle with 3 tick marks and 2 tick marks. So 2, the ratio I can set up is here. What goes between 2 and 3 tick marks in this, on the right-hand triangle? Yeah, 10. Right, so I can put 2 is to 10 as 5, that's the other thing I'm given, right? 5 is to, so I'm always starting with the left-hand side and then going to the right. 5 is to, well, this is going from 1 tick mark to 2, so between 1 tick mark and 2, those angles is the distance x. So here's my proportion. And we know how to solve these using cross multiplication. Remember, we would take 2 and multiply it by what's across from it, x. So we'd end up with 2x. Bring down the equal sign, right? We always bring down the equal sign. And then I'm going to take 10 and multiply it times 5. So that's cross multiplication. So 2 times x is 10 times 5, or 2 times x is equal to 50. Divide both sides by 2. These 2's cancel. I'm left with x is equal to 2 into 50 is 25. So the distance x is 25 units. I didn't tell you what the units were, so we'll just say it's 25. Great.